Today, we're diving into a topic that's often discussed but rarely seen in action: the hydrogen economy. Specifically, we'll explore whether Plug Power's ambitious green hydrogen network is finally beginning to deliver on its promise. This isn't just about a new fuel, it's about a decade-long monumental experiment in industrial energy infrastructure aiming to fundamentally reshape how we power our world. The stakes are incredibly high, and the journey has been long and complex. The core question we're addressing is profoundly simple, yet its implications are massive. What happens if Plug Power's green hydrogen network actually works? They've invested billions in building a complete hydrogen value chain from the ground up. Their ambition is built on three pillars. First, leveraging renewable electricity from wind and solar to produce hydrogen through electrolysis. Second, creating a full value chain that encompasses everything from production and liquefaction to distribution, storage, and end use. And finally, establishing powerful network effects by building both supply and demand simultaneously, aiming for a self-sustaining ecosystem. Consider the scale of the challenge. Building a comprehensive energy infrastructure typically takes generations. The oil and gas industry, with its vast network of pipelines, refineries, and fueling stations, evolved over a century. Our modern electricity grid, with its power plants, transmission lines, and substations, also took more than 80 years to establish. Plug Power, however, is attempting to construct a robust hydrogen network, including electrolyzers, liquefaction plants, specialized tankers, and fuel cells, in just about a decade. This is an unprecedented race to build what hydrogen currently lacks compared to established energy systems. Plug Power's vision for a green hydrogen network involves a fully integrated five-stage process. It starts with renewable electricity generation, harnessing power from sources like solar and wind. This energy then feeds into electrolyzers, which split water into hydrogen and oxygen. The hydrogen is then cooled to an incredibly low -253 degrees Celsius for liquefaction, making it efficient to transport. From there, it's distributed via specialized tanker trucks to various sites. Finally, it reaches its end use in fuel cells for things like warehouse logistics, heavy transport, or industrial applications. The key here is Plug Power's control over this entire value chain, creating a unique, vertically integrated ecosystem. So, where does hydrogen truly shine? In warehouse logistics, hydrogen forklifts refuel in minutes, enabling continuous operation across long shifts, a critical advantage over batteries for major clients like Amazon and Walmart. For heavy transportation, especially long-haul freight, fuel cells outperform batteries in range and payload, with the only byproduct being water vapor. In heavy industry, green hydrogen is pivotal for sustainable steel production and replacing natural gas feedstock in processes like ammonia synthesis. And importantly, it offers grid energy storage, converting excess renewable electricity into hydrogen for long-duration storage, then converting it back to power when needed, stabilizing the grid. A reliable regional supply network is the critical missing piece for widespread hydrogen adoption, particularly in trucking and industrial sectors. Plug Power is actively building this out across the United States. They have an operational green hydrogen plant in Georgia, supplying liquid hydrogen to industrial customers and logistics fleets. In Tennessee, a production facility is expanding capacity to serve the Southeast Corridor, and another is under development in Louisiana, targeting the significant industrial demand along the Gulf Coast. These facilities, along with additional planned sites, are strategically designed to form crucial regional supply corridors. Plug Power's strategy is fundamentally about creating a self-sustaining loop by simultaneously building both supply and demand. On the supply side, they are developing green hydrogen plants, advanced electrolyzer technology, liquefaction systems, and robust distribution logistics, including fueling infrastructure. This drives more production capacity and expands their customer base. On the demand side, they are deploying fuel cell systems and forklifts, establishing truck fueling stations, and engaging industrial, airport, and port clients. This, in turn, generates more demand and ensures better utilization of their assets. This integrated approach aims to create a virtuous cycle of growth. Despite the promise, success is far from guaranteed, and Plug Power faces significant risks and challenges. Economically, the cost of electricity, equipment efficiency, and utilization rates heavily impact hydrogen economics, especially given the high energy demands of electrolysis and liquefaction. Technically, hydrogen properties, such as its propensity for leakage and the need for cryogenic temperatures or high pressure, demand specialized infrastructure. Operationally, controlling the full supply chain brings integration risks. A failure at any single point can disrupt the entire system. And competitively, if hydrogen doesn't succeed, industries may pivot further towards batteries, electrification, or synthetic hydrocarbons. This integration offers competitive advantages but also concentrated risk. If Plug Power's network truly works, the implications for the energy system would be transformative. Hydrogen would become a widely distributed energy commodity, accelerating investment and deeper government policy support globally. We'd see significant industry shifts towards hydrogen technologies, rapid scaling of green steel, green ammonia, and hydrogen-based chemicals. Crucially, hydrogen would stabilize the renewable grid through long-duration energy storage. In the bigger picture, hydrogen bridges the gap between renewable electrons and the industrial molecules essential for many processes. Like oil, its success depends on robust infrastructure. It's not just a fuel, but a key to managing our future energy needs. The future of hydrogen won't be decided by announcements or press releases, but by whether networks like Plug Power's can operate reliably, economically, and at an industrial scale. Plug Power represents the world's most ambitious real-world test of the hydrogen economy. If they succeed, it will prove hydrogen can indeed be a distributed commodity, unlocking global financing and policy support. If they fail, it will likely accelerate the pivot towards batteries, broader electrification, and synthetic fuels. Ultimately, hydrogen has the potential to be the vital bridge between renewable electrons and the industrial molecules that power our modern civilization.